Okay, so hello and welcome to this Hyperledger Sweden meetup on this sunny and hot Saturday. Today's topic is TLS, and we are going to extend our existing network. And I will show you first a short agenda, what we would like to do today. As some of you know that we have a larger example. So there's a consortium called sunshine.com. And in the last session, we have did some work. We have created a basic consortium. And today we are going to extend this consortium with TLS. And I will give you some theoretical background, a high-level overview, what is TLS and which kind of methods are, can be used. We have a one-way TLS, that's the normal TLS, which you also know from your browser when you surf in the internet and you use HTTPS protocol to send secure or to surf secure on the internet. And the second way is the two-way TLS, and also known as mutual TLS. And I will show you the difference between these both methods. And in Fabric you can use both methods, and we will see how we can extend our existing network with this level of security. And because of that we are using cryptogen, I will show you also where these certificates are established, how you can find these certificates, how you can inspect these certificates, and I hope that's a little bit the different part that, but I think I have a good visualization, and with this we can show this and make this a little bit clear. And of course, in the end, I will show you the practical implementation of this TLS example and how we can extend our network with this. And in the end, as I have mentioned, also for the next session, we will have, I hope it will be a guest speaker. And this guest speaker will tell us a little bit about the raft ordering system. So I hope that will be, and yeah, we will see next week. We will hear really interesting stuff about the raft ordering system. Okay, so what about TLS? TLS stands for Transport Layer Security. And Fabric supports two kinds of methods to communicate with two kinds of methods you can secure the communication between the buyer, another buyer, the orderer, and also the clients with interact with the system. And as I have mentioned, we have the one-way TLS version. So that's normally what you use when you use your browser. It's exactly the same system. And the two-way or mutual version, where the server and the client authenticate against, and that's another layer of security. And these both methods you can use to secure the communication in a Fabric network. So what is the one-way TLS? So I will give you here a high-level overview, and I think most important is here the picture. So we see here a TLS client and the TLS server. And the TLS server has, the TLS server has a public key or a certificate, and because the certificate, in the certificate is also the public key involved, and the private key. And the client doesn't have any key. And The process, that's the same process as we can see it in the browser when we use the HTTPS protocol. And here you can see in high level how this works. So it's a little bit complicated than here in the picture, but I think we can understand with this the main difference between the one-way and the two-way TLS. So we can see the client send a message, the client says hello, and then the certificate and the public key in the certificate is also the public key will send to the client. And the client checks, is this certificate valid with a number of certified authorities. In the browser knows certificate authorities and checks if this is a valid certificate. And if this is true, there is a key validation, some key validation, because TLS is a mix of symmetric and asymmetric encrypted encryption methods. And there is, when you want to know more about this, KC wrote or published this week a very interesting article. I can show you the link later. And this is really interesting, and you can read a lot of more about the history of TLS and how the things work together. So that's a really good article, and I recommend to read this article if you want to know more about the TLS. And then we have encrypted data. But the main thing here is that the client doesn't have any key store, the client doesn't have any certificate or private key. Only the server has this, and the client only looks, okay, is this a valid certificate, this server, and can I trust this server? From the server side, from the server side, there is no control about the client. So the server cannot say in the one-way TLS that the client belongs to this certificate authority and has a valid certificate. And that's basically how the one-way TLS works. And yeah, and the two-way certificate does basically the same, but as you can see here in the picture, the client has also a key store and has also a public key and a private key, and the server has a public key and a private key. And the process is basically the same, but in the when in the first step, the client checks the server certificate and say, okay, this certificate is valid, and I have checked this with my known certificate authorities, and I can trust the server. And then in a second step, or in a further step, the TLS client sent also his public key to the TLS server. And the TLS server checks, okay, this certificate, this client with this certificate belongs to a known certificate authority, and checks if this is valid. So in this scenario with the two-way TLS or mutual TLS, we can say that the client, the server knows something about the client, and the client knows something about the server. And when both say, okay, we are from the same certificate authority, or we trust the issuer from the certificate authority, then we have a valid communication, and we have a secure communication. So I have here a sentence. So the main intent to use a two-way TLS connection is when a server should only accept TLS connections from a limited group of allowed clients. So with this, you can say only my members, my certificates, my members of the fabric network can communicate with this system. And for this, we have a separate certificate. We will see it a little bit later. That's called a cert. So the name is cert key and cert pub, and we will find it. And yeah, so, and that's the difference between these both methods in a high level. So when you compare it, the client has no key store in the first version, and the client can only check that the server is a valid server, and I trust this server. But the server cannot verify that the client is someone who belongs to this server or to the system, or can anything check who is that client. And that could be done with the two-way TLS. And here you can see we have a check from the client side, and we have also a check from the server side. And so with this, you can make sure that only known people or only known clients, peers, orderers, and or in general or in more general members from our network can communicate together. So these are the difference between these two versions. And when it comes to the cryptogen tool, so that's interesting to see. So cryptogen creates all the crypto material and creates a lot of certificates in a specific structure. And we have in this tree, in this folder tree, we have two sleeves. One is the orderer organization and one is the peer organization. And in the order organization, you will see in our structure this folder structure. So we have order organizations, then we have the sunshine.com, and then we have here two folders, TLS CA and orderers. And in TLS CA, here we have a PEM file certificate. And when we look into this certificate, we will see that the issuer is equal to the subject. And that means that we have a self-issued certificate, and that's basically our TLS CA sunshine.com. So this is our certificate authority for TLS. And in general, you can say you have a certificate authority for TLS, and you have a certificate authority for the orderer organization and or for the organization and for their member. So for the TLS, you have always a own certificate authority. And this certificate authority issue certificates only for the TLS process. So in our scenario, we have only one orderer, so the orderer sunshine.com, and here we have in the structure TLS folder, the TLS folder, and there we have three files. We have a server cert, we have a server key, and we have a ca.cert file. And that's the same as here. So the cryptogen copies this certificate in a lot of different folders. So therefore here's the same color. And this certificate TLS CA sunshine.com cert PEM is the same like this. So when we configure our system for TLS, then we can use this one for the orderer or this one. So it's the same. And later I will show you how you can inspect this with the OpenSSL tool. And then you can see it's exactly the same file and the same certificate. So and cryptogen copies simply this certificate and name it the CA cert. So, and that's the root TLS cert for the orderer here. And the server cert file. This is the certificate of the server. And in this certificate, we will have the public key and the signing cert. And the server key, that's the private key. The private key will never send to any other position here. And this is I think an important part that we have for the orderer. We have an own orderer certificate authority. Yeah, we can find this in this structure here. And this certificate authority creates for every orderer here a key pair, a server cert, and a server key. And when we see next week, when we hear next week the presentation about Raft, then we will see that we need for Raft more than one orderer. And then when we check this structure, then we will see that we have here orderer 0, orderer 1, orderer 2, and so on. So we can have here, of course, more orderers, and every certificate is issued from this TLS CA. Yeah, so we will see the same system in the peer structure. And as you know, we have two peers, a peer 1 and a peer 0. And that's basically the same. But important here is that cryptogen simulates certified authorities and creates a TLS certified authority for our system. And this is the root TLS certificate, and this issue quasi the server and third and the server key here. And the TR third file is only a copy from this one. And you can use this one or this one. So, yeah. And when it comes to the peer, and in the peer scenario, we have the same structure. So we have order organization, and then on the same level we have peer organizations. And the peer organization, we have the producer sunshine.com organization, and that's the same structure. So we have also here TLS CA, and we have also here TLS CA producer sunshine.com. So we have our own certificate authority for this organization. So when we look back to this, we have a TLS CA sunshine.com. This is our organization, the orderer organization. And when it comes to the peer organization, we have here, this is our peer organization. When we have a second organization in our network, then we will have the same structure on another level. So, but you have here producer sunshine.com, and you have for this organization your own certificate authority. When you have here trading.sunshine.com, you will have here another certificate authority with this a separate certificate authority for this organization. But the process is the same. So this is our root certificate for this organization, and this is and when we inspect this file, you will see that the issuer is the same as the subject. So the issuer is always the issuer, I don't know how I should explain this, and the subject is the name of the owner of this certificate. And when we have here a TLS certificate for the PS0, then we can see that the issuer is not equal to the subject. And the subject in this case is the PS0 producer sunshine.com, and the issuer is the TLS CA producer sunshine.com. And also the server cert and the server key here is created. And here also cryptogen copies the root TLS certificate into this folder. So when we have here the peers, we are on peer 0, we are on peer 1, and I have copied this here, also the server cert from the peer 1 and the server key from the peer 1. And then we have here a copy from the root TLS certificate from our producer sunshine.com organization. So I think important here is to recognize that every organization, order organization or a peer organization has its own certificate authority for the TLS process. And that's important. And yeah, and the rest is the same. As you can see here, we have the server key, we have the cert, and we have here a copied TLS root certificate. And so this is the structure. And when we want to enable this, for example, for the TLS one-way version, we can do this with a set of environment variables. And these environment variables are set in the Docker Compose file. And I think there are 3 files, or 3 variables. And one variable is to enable TLS in general. So, but the variable names are not the same. So for orderer, we have this kind of orderer general TLS enabled, and for the peer you have a different name. So it's not, these variables are different between orderer and the peer. And so, okay, that's, I think when you set true, then TLS is enabled. And when you set this to false, or this variable is not set, then TLS is not enabled by the orderer. And then we have to set 3 environment variables. And we have here the private key, the TLS certificate, and the root TLS certificate. And these are the 3 files I have shown you previously. And for these 3 variables, we have to set a path to the server key, to the server cert, and also to the CA cert. And you have to do it in a full qualified path. So that's maybe something I would like to note. So that means that that's an absolute path and not a relative path. So an absolute path in the Linux environment starts with the /. Yeah. So that's important. So a full qualified path is an absolute path. So, and it starts with the root and the / here, and it's always from the root to the point where the file lives. So that's important to know, full qualified path. And then the private key is simple to know, server key. So the key is the sign, the sign for the private key. And the CRT, server CRT, is the certificate. And the certificate is includes the public key and the signing cert. And the TLS root CA, this could be also an array. So we will see this later in the Docker Compose file. So there could be more than one root CAs, and therefore it could be marked as an array. And these both files are a single string in the Docker Compose file. So and this must be full qualified path. So, and that's it. So I think that's clear. And for the peers, we have the same, but the name is a little bit different. So the name is core peer, TLS enabled core peer TLS key file, and core peer TLS cert file, and so on. So, but the meaning is the same. So the key file is the server key here, and the cert file, this is the private key. Yeah, and the server cert is the certificate with the public key and the signing certs included. And yeah, the root cert file could also be an array, and it's the CR cert file. So in cryptogen, as I mentioned, copied these 3 files in one order, in one folder, and that makes it easy to link to this position. Also, when you have a distributed network, so in our scenario, we have one machine, and every Docker container runs on the same machine and have access to the same cryptogen folder. So that's easy to link all files and organizations and peers to this cryptogen folder. But when it comes to a decentralized system, when you have, for example, a Docker Swarm system and you use an overlay network and you have one peer in data center A and the second peer in the data center B, then you don't have the crypto folder on the same place. So then you have to copy the crypto folder to the proper location. And maybe for that, they copied all 3 files on the same position. But you can use also the root TLS, as I have mentioned before. And here's the same note that these are absolute paths. Okay, so two-way. And for the two-way environment, there are 3 more environment variables. So for the peer, this core peer TLS client out required is true. So that's a new environment variable. So, and then we have 2 new files. So when we see, this is called the client cert and the client key. And when we look into the folder structure, we will find a client cert and the client key. So, but we will see that later. And the client means peer or user. So a user is something when you maybe you have when you have your Node.js application and you try to connect to a peer with the Node.js application, then you need also a client from the certificate authority, and these are from the type user or client, and the peer is clear, that's the peer node. And for the order, it's the same. There are 2 environment variables and also a general environment variable to enable this kind of authentication, and then here the client root CA path. And yeah, so, and with this environment variables set in the Docker Compose file, we can enable TLS in this way. And of course, when you have enabled one-way or two-way TLS, then you have to use it as well. Here's an example for the chain code invoke command. When we say here that we have here the TLS enabled, so that's done with this option. And then here we have the CA file here, and then we have the client out. Yeah? The client out is true here, and we have the key file, and we have the cert file. So when one-way or two-way TLS is enabled, then you have to use this environment variables in different kind of ways. When you have the CLA version, then you have to do it in this way. When you use the Node.js version to connect, to invoke or query some data, then you have to do it in a little bit different way. So, but that comes with maybe as an overhead. for the CLI version. So, and for this, I have set push environment variables so that I can define environment variable for the TLS orderer CA file for the orderer certificate. So that reduces here the amount of text, and so it's a little bit easier to control the command here. So the client is the current user, the client admin user 1. So that means that when cryptogen is generated, all the crypto material, we have also by default one client, one admin user generated. So we need this admin user to join the channel and so on, to install the chain code. And also a normal user from the type client is also generated. And then we can try to switch between these two types of users, and then we will see that when we change that the user 1 has another client certificate than the admin user. So of course, but this is important to know that every client has, of course, its own TLS certificate and its own TLS private key. Yeah, but okay, so, and that's also an important part. You have to know that only when you invoke something with the orderer, you have to use this TLS variables and client out variables. But when you query your peer from the CLI, yeah, you don't have to use it. So we can test it. So we can only say when we query, because we query the peer, which belongs to through the environment variables, which are set when we create the CLI peer. Okay, so, and here, some commands, how we can inspect these certificates. So this is the OpenSSL tool. And with this command here, we can look into this file and we will receive a human readable format that we can see who is the issuer, who is the subject, how long is the certificate valid, and so on. So we can look into this. And here are two examples for the orderer structure, and here for the peer structure. Okay, so yeah, so that's a little bit from the theoretical side. So here in my slides, here's the reference to the Fabric to read the docs to the 1.4 release, and then I have copied the example from the last Saturday, and in the example 02, I will have the TLS variables included, and now we can try to see how this works. So I'm going to do this a little bit larger. So, okay, so for this demonstration, okay, the system is the same like last week. So I have copied it and in another folder, and it's the same. And the only thing I have changed is here in the peer base file. And for the peer, we have a base file with environment variables which are used in every peer. And as we can see here, enabled TLS, that's here the part. So we have the TLS enabled environment variable for the peer, and here are these certificates. And you see the paths here. to the server cert, server key, and TLS sales. And you see, these paths doesn't look like that they belongs to the cryptogen folder. So, and that's the basic structure where the peer looks for this TLS certificate. And we mount, when we look here, when we see here with the peer 0, so we have here a mount point, so under the volume section. So here we mount this, yeah. So it's basically the same what we have done for the membership service provider folder. So from the viewpoint from the peer, the structure is the same. So you have etc Hyperledger Fabric path, and there is an MSP and TLS folder, and we map this with our cryptogen folder. So, and here you can see, so we have peer 0, yeah, and the crypto config path is something like we have seen in the picture. So we have the beer organization, we are in the producer sunshine.com. We have different beers. So we pick beer 0, and beer 0 will have a TLS certificate. So, and we can check if this is true. So when we look in this crypto config folder, yes. And you see here, and that's our mount points. And you see here the membership service provider path. And then we see here the TLS folder structure. And here are these files. Yeah. And this mount point, here mounts the TLS files to this location. And in the peer base command, yeah, we see here the final destination from the files, and they are mounted here. So you cannot say, you cannot give here the crypto config path from the crypto config, because the crypto config path doesn't exist into the peer. So, and that's the reason why we have to do this in this way. So, and that's important. So we mount the TLS folder, and it doesn't matter where this TLS files are stored. So, but we mount these files, yeah, to this standard location. And that's the same process as we have done for the membership service provider. Yeah. And that's for all these files. So, and you have here the server cert, the key file, and the CA file. And now you can see, so it's pretty easy when cryptogen copies the root TLS certificate in the same folder structure. And the only thing we have to do is we name this file here, and then we have a proper path to the root cert file. So that's pretty fine. And the same is for the two-way TLS. So we have to set for the client, this client out required, wherever to true. And then we have to set this server cert and server key file as well. So, and as you see, these are the same files for this. No? And for the orderer, it's the same. So, and we have here the orderer, the TLS. And you see here the example with the array. So we can have here more than one root certificate. And so that's an array. And the system is the same. Only the environment variables have a little bit different name. So yeah, that's the only difference here. But also for the orderer, we have mounted this folder here. Right? Here's the cryptogen, orderer organization, sunshine.com, orderers. This is the orderer one, orderer sunshine.com, and has a TLS folder. And this folder is mounted to this standard position here, to the standard structure. And then we can make the same. So we have also here, but here notice that here is the orderer and not the path is a little bit different, but this is also the standard path. And you see here etc Hyperledger fabric and here wow Hyperledger orderer. So there's a little bit different path for this. And to enable two-way TLS, yeah, it's the same here. And I think with this, you have enabled TLS one-way and two-way in our system. So in the GitHub repo, in this example 02, you have also this README file. So, and you can see here the informations and the paths what we have. And then, so now we can test, we can try to test this, if this is working. So for this, so we can test and start our network. But okay, we can do it later. And so now we have to switch into the system. So and you see here. Sorry. So. And here, what we are doing now is, so the system, we have to create the channel new, we have to join the channel, we have to update our anchor peers and so on, and we have to install the chain code. So, and but the example is the same like in the last week, but now we have the TLS two-way enabled. So. And for this, we have to set this environment variables. And so I can show you how this works. So, okay, we have a channel name and we have a TLS orderer, a CA path. So, yeah, and we can this export in our peer container. So, yeah, please note the printf command. And so here with the core, yeah, when we grab this with the core, so we see these specific environment variables which are set. So here also our peer0, CLI, TLS is enabled, and so on. So client auto required is also enabled. So, and the channel, okay. So with the channel name is my channel. So then we need two more environment variables. We have this client set file and this p file. So. And then we can create a channel. So, and the command is the same like last week, but the only thing changed are these options here. So the first option is to say, okay, it's TLS. Then we need the path to the orderer, TLS orderer root file. Then that's here defined. And then we need the client. We need to say we have client authentication enabled. This is done with this option, and then we need the key file and the cert file. And the key file that's from the user who will create this channel. And as you can see, that's the admin. So the admin user can create a channel, and therefore the client is the channel now. The client is the admin now. So with this command, you can see we have successfully created the channel. So now we have a channel, and then we have to join the channel to the peer. And for this, we don't need the TLS. But also, when we make the update, when we make the update transaction for the anchor peer, so he is also the orderer involved. So when the orderer is involved, we have this TLS communication. When we communicate with our own peer, then we don't need TLS because we don't leave the peer. So that's the reason why we don't need here any TLS information. So, and that's the same. So that's the same like last week. And then here, these options are required for this TLS configuration. And we have successfully submitted the channel update. So then we can switch to peer 1. And this is done by the change of the environment variables core peer address. And we can join also on peer 1 to this channel. So here with the command peer channel list, you can check. You can see channel P has joined. And then we have to install the chain code. So we go back to the peer 0. And then we install the chain code. It's the same chain code like last week. So, and you see here on this command, it's the same command. There is no TLS information because we install this chain code on this peer. So nobody else is involved in this process. So we don't need TLS. But installing a chain code is a two-step process. So first we have to install it, and then we have instantiate the chain code. And for the instantiation, we need the orderer transaction. So, and now we leave our peer and send some information to the orderer, and these traffic should be encrypted and secure. And for all transactions which leave the peer or to the orderer, we have to set the TLS configuration. So, and that's really important to see, to understand why when we don't install it, we don't use the TLS. So, and when we instantiate this, and you see, everything should work. Then we can switch to the second peer, and we do also the install command. So when we have in our scenario, we have one organization, we have two peers, and we want that both peers are endorsement peers, then we have to install on both peers our chain code. But we only have to instantiate the chain code once. So when we add a third peer, we can, it doesn't make sense to instantiate the chain code again, because we have channel, we have blockchain data, we have data on this channel. So a new peer should synchronize all the data to his location. And yeah, that's the reason why when we install and instantiate a chain code on a channel, then we only have to instantiate it once. So export, okay. Okay, so now we are on peer 1. So, okay, here we have in this instantiation, we have also for our first transaction is done, and this is the key message 1. And now we are in peer 2. So and we can query now. So we can query this peer 1, and you see, okay, hello. So, but we have queried our own peer. So there is no TLS transaction between the peer itself. But when we try to invoke something, invoke the chain code. So that's also two-way. So and then we say chain code successfully invoked. And when we query, you see one-way TLS, but the text is not true. It's two-way TLS, but now so now we see we are on peer 1. So let us switch back to peer 0, and we query again, and you see the same information. So in the background, peer 0 and peer 1 are synced, and I can query the same information from peer 1 and peer 0. Okay, so and that's also a cool example. So now we are so now we are the admin. So as you can see, the membership service provider config directory, config path, yeah, is linked to the users directory, and we have here the admin user. So the admin user. So, and of course we need this admin user because only the admin user has the proper rights to create the channel and install chain code. But a normal invoke transaction or a query transaction can also be done by another user. So, and not by the admin user. So we can change this as well. So, but when we do this, we have also to change the client key, but we will do it in 2 ways. So now I change this environment variable. So now, so we are user 1. And when we try now, so for the query, it doesn't matter. So for the query, we don't need TLS, yeah, it works. So, but when we try to invoke something, so we set message 2, oops, then I think this should not work. So, okay. And when we query this, we have the same information. So, okay. And last thing I want to show you are this OpenSSL command here. And when we try this here, so when we look at this here, this is the TLS CA sunshine.com cert, and you see here the issuer information, and you see here the subject information. Yeah? And you see these are the same informations. So, and that means that this is a self-signed certificate. So, and you can also inspect here the validity, yeah, not before, not after, yeah, how long is this certificate valid? Yeah. And with this command, when you look also in the, you can check this as well. So, and you see here, and you see here, this is the Aurora server certificate. And you see here, the root certificate, the issuer, is the TLS sunshine.com. But the subject has an other common name. So CN stands for common name, and it's the Aurora sunshine.com. Yeah? So, and this certificate is the certificate from the subject, from the Aurora sunshine.com, and this certificate belongs to this root certificate authority. So that's what I have shown in the in the slides before, and you can see also the same information here. And for the beer, is it the same? So, and you can also inspect this certificate. And you see the issuer, yeah, and you see the subject. So then the issuer common name and the subject common name is the same. And then we will have a self-signed certificate, and yeah. So, and that's maybe not the best from this when it comes to security. So here it must be another certificate from other root CA. So, and that's also the reason I think where we should have in a productive system, we should have TLS root CA, and we have an intermediate CA, and you can have different intermediate CA. So yeah. Let me check this one. And you see here, these are the cert for the peer 0, and you see here the same. Yeah, the issuer common name is the TLSCA, and the subject is the peer 0. And you have here for every organization a TLS certificate, and so that's an important part, and that you will have for every organization, for the other organization, and for the normal organizations, you have a single certificate authority which is only responsible for TLS. And cryptogen does this for you, create these files for you. So, okay, I think now I'm at the end of my presentation. So let's recap these steps. So I think the important part here is that we have to know that we have to link the TLS folder to the corresponding TLS folder in the peer or in the order. And when we use cryptogen, all certificates are copied from the cryptogen tool in this folder structure. When we do it with the Fabric CLI, when we do it per hand, for example, then we have to copy these files by our own in this structure. And that's the reason I think why we should start with cryptogen, so we can really learn to understand the structure and why the structure of TLS, MSP, and so on is organized in this way. And when we know the structure, then it's very easy to create your own certificates and copy the certificates on the right location. And you have to define then some environment variables. Yeah. So, and if you use one-way or two-way TLS, I think this question depends on your business. So, and but I think the most times one-way TLS is used, but you have seen you can easily extend or increase your security with these two-way TLS here. Okay, and for the orderer, it's the same. Yeah. Notice that you have different names, different variable names here, the orderer TLS, yeah, and the client authentication. So, yeah, so if you want normal TLS, you don't need the two-way, so you are good to go only with a one-way TLS. It only works. And when you do prototyping and you have a solo orderer and you have all on the same machine, then I think you don't need TLS. It's my opinion, because nobody has access to your traffic on your own machine on the same host, and of course in the Docker network. And when it comes to a decentralized system, when you have a Docker Swarm system, then you can also say, okay, now we have a data center 1 and we have a data center 2. Between is the internet, and we have to send the data from A to B. Then I would like to mention that Docker Swarm has also a layer of encryption. So you can also encrypt the overlay network from the communication. And that's also another way of security where you can increase the level of security when it comes to these transports topic. So, okay, I think now I'm in the end of my presentation. Later, I will upload my slides and post it on in the Slack channel, and in this GitHub repo here you can find the example. So please try it, and I think you can easily reproduce this example. You find all the informations here, and I have done a lot of documentation here so that you know what is. And maybe this is a good point here when it comes to problems and error logging. So you can log the orderer logs, for example, all errors with this command, and redirect the error and the normal commands to to this pipe command, and then you can filter only errors, for example. So because when you look here, you see a lot of traffic happened and you can't see the error here. And so you can, with this grep command, then you can filter this error here out. Okay, so I have to say thank you for your time. I think today we are good in time. And that's from my side. Next time, as I've mentioned, maybe we will have a guest speaker, and this is Nathan, and he will tell us something about the Raft ordering system, and that's pretty cool. And the TLS section from today, this is a good starting point, because we only can use Raft as an ordering system when we have enabled TLS. So the TLS part is, I think, important to know when it comes to Raft, when you try to change our solo ordering system to a Raft ordering system. Okay, so that's from my side. Do you have any questions? If not, then thank you for your time, and have a good learning week. And yeah, see you next time.
Thank you. Thank you, Roland.
Welcome.